My name is Claudio Sepulveda from UC San Diego. There is a growing trend to use deep slender columns in steel special moment frames due to its greater stiffness allows to accomplish the drift requirements from seismic codes with cheaper elements. However, it brings with it a higher probability of local and global buckling. Member level and just a few subassembly level studies have been done in the past. So that is the reason, because during my PhD I have been working on a full-scale hybrid simulation test to analyze this kind of members during an earthquake and considering its interaction with the rest of the structure. This project is funded by NIST and it's a collaboration between the University of Michigan, UC San Diego and the laboratory ENCRI in Taiwan. Regarding to the test, I was trying with different setups in order to capture the behavior of the subassembly to be tested, but using as few actuators as possible. After a couple of simulations, we decided to implement an approach where we overlap the domains between the numerical and experimental subassemblies. For the experimental part, we will test 1/2 story of a column and 1/2 of a beam on both sides of the column, assuming that all the elements have an inflection point just at the middle of the element. 3 actuators and 1 hydraulic jack will be controlling displacements and forces. Particularly, the horizontal actuator on top of the test will be controlling the horizontal displacement of the panel zone in order to ensure that both the numerical and experimental part have the same horizontal displacement at the first story. Finally, due to the overlapping approach, the forces of each actuator will be combined internally into OpenFresco to send as a feedback from the test to the numerical subassembly the moment, shear and axial force to the bottom node of each panel zone. This approach allows to capture the complexity of the interaction between the panel zone, the nonlinear behavior of the reduced beam sections, the composite slab on top of the beams, and the buckling of the columns using just a couple of actuators without imposing an inflection point just at the middle of the elements in the numerical part, and finally simulating the transferring of inertial forces up the first story without any discontinuity in the numerical part.